With the exponential growth in the Indian cold chain industry, it has been termed as a sunrise sector. Still, India faces an acute problem of appropriate refrigeration facilities, leading to 1.3 billion tons of food perishing in India. With a large spread of arable land, India is the world's largest producer of milk, fruits, vegetables, seafood and meat. Over 80% of the cold chain industry in India is unorganized and uses outdated and archaic technology, resulting in gross inefficiency and food loss. The cold chain industry is expected to grow at a CAGR of 14.3%. With the advent of food delivery, favorable government policies and innovative technology. With this market growth potential in perspective, we introduce South Asia's premier refrigeration and cold chain exhibition, RefCold India, which has a rich legacy of connecting experts and which enhances opportunities. After successful editions in Ahmedabad and Hyderabad, RefCold India is all set to catalyze the growth from the 12th to 14th of October 2023 at the Chennai Trade Center.
I welcome all of you to Chennai.
With a coastline of almost 1100 kilometers, Tamil Nadu has been identified as a champion sector for boosting exports and helping the state realize its goal of becoming a $1 trillion economy by 2030. RefCold India is a state-of-the-art exhibition positioned at the very horizon of innovation. Key progressive innovations of the industry will be on display, with insights by the decision makers. With over 200 exhibitors, the exhibition would feature an innovation zone and a B2B networking area. RefCold India caters to industries such as fisheries, agriculture, horticulture, pharma, dairy, poultry, food preservation and reefer logistics. The RefCold India Awards Night will highlight and honor those at the forefront of this burgeoning industry. The Indian Society of Heating, Refrigerating and Air Conditioning Engineers is an organization dedicated to the advancement of the arts and sciences of the HVAC-R industry. Informa Markets in India is known for its expertise across the B2B exhibition sector and its ability to create innovative business platforms. It has collaborated with the Indian Society of Heating, Refrigerating and Air Conditioning Engineers to present RefCold India 2023, South Asia's forefront exhibition for the refrigeration and cold chain industry. We invite you to join us in Chennai from the 12th to the 14th of October for RefCold India 2023, South Asia's premier refrigeration and cold chain exhibition.
Good evening, everyone. This is Krishnamurthy. Hello.
Hi, Sriram here. I'm able to hear you.
Yes, sir. Yes, sir.
Praveen, are you there?
I'm here, sir.
Okay, do you want to test that video and see whether it's okay?
We just play the video, sir.
You just played the video, is it? Okay, you're fine. Riaz is still not joined. Once he joins, you can test
So, Praveen, I think you can play it once again so that we can be doubly sure that video and audio quality is good. Yeah, okay.
With the exponential growth in the Indian cold chain industry, it has been termed as a sunrise sector. Still, India faces an acute problem of appropriate refrigeration facilities, leading to 1.3.
No, this is fine.
Once Riaz comes in, we will just check whether he's able to share.
The slides are, yes.
And then we'll start.
Thanks.
Greetings from ISHRE. I'm Yogesh Thakkar, President, ISHRE Society at 2324. As most of us know, ISHRE, Indian Society for Heating, Refrigerating and Air Conditioning Engineers, has a strong membership strength of 25,000 professionals and students. The entire world is looking at India at its rapid growth story. As India moves towards becoming a 5 trillion economy by 2025,
are you having a problem?
Our industry is going to see a positive growth rate, CAGR.
Just try again.
No, you're not able to log in, or is there an internet problem?
Actually, connection is, it seems a network issue.
Of 15.8% from the year 2021 to 2030. As ISHRE, in this term, as president, I have identified two major core areas for the society to focus on: decarbonization and skill development. An actionable program has been designed to achieve this by initiating targeted activities with the government by conducting active digitalization drive in ISHRE. This will in turn help the industry as a whole. As the president of ISHRE, I hereby launch the ISHRE presidential theme for the society year 23-24.
Unveiling presidential theme: engage, educate, elevate. These E's shall become key pillars of ISHRE's future growth story. Our vision will be backed by appropriate action plans. Engage. We at ISHRE engage with our members, youth and women, and empower them to act in a befitting manner. We also aim to enlist the support of our associate societies and jointly work with the government and industry. We need to entrust the future to our student members and the K-12 children. Educate. We aim to enrich knowledge by conducting educational workshops, research papers and technical publications. We shall develop codes and standards and offer guidelines for their implementation. We will strive to evolve enhanced e-learning programs with a strong digitalization drive. Elevate. We will put our focused efforts to elevate our HVAC and our industry, and by extension the entire built environment, to be a significant contributor to the growth of the Indian economy. We will bring about this growth through sustainable development by creating energy consciousness and engineering efficiency, thereby helping to enable resilience through decarbonization. Through our consistent efforts towards creating an engaging environment and spreading education, we plan to achieve an overall elevation of the entire ecosystem of the HVAC and our industry, and thereby fulfill the objectives of the presidential theme for this year, that is, engage plus educate to elevate.
this theme shall be the guiding force for the future of ISHRE. So I invite you all to be a part of this dream and take ISHRE and our country to newer levels of sustainability with better presence, visibility, and influence.
I think Mr. Riaz can't join. Riaz, you are able to hear us?
I'm able
Hello.
to hear you, sir.
No, no, Riaz is able to hear us? Sir Riaz? Okay. Can we get started?
Yeah, great.
Manoj and Praveen, shall we get started?
Yes, sir. We are eagerly waiting, sir. We can get
Okay.
started, sir.
Riaz, I hope you are ready. Yes. Okay. Good evening and very warm welcome to all those of you who are here. This is the sixth in our series of webinars that the RefCold committee is holding. These lead up to RefCold 2023, which all of you know is between the 12th and 14th of October 2023 at the Chennai Trade Center, Chennai. RefCold is a refrigeration and cold chain exhibition organized by ISHRE, the Indian Society for Heating, Refrigeration and Air Conditioning Engineers, and it is South Asia's largest refrigeration and cold chain exhibition. After successful shows at Hyderabad and Ahmedabad, Gandhinagar, the sixth edition of RefCold will be held here at Chennai. The webinars that we have been conducting one every fortnight for the last 3 months nearly, is to create a conducive climate to hold the exhibition. And we plan to have a couple of more webinars by the time the exhibition is on in October. An exhibition of this magnitude in the HVAC&R space is actually coming to Chennai after about 25 years. Incidentally, today is Chennai's birthday. Madras, as it was then known, was found more than 300 plus years ago on this day. This exhibition will have more than 150 exhibitors covering more than 3,500 square meters of exhibition space. Most of the exhibitors are, what should we say, dadas of the refrigeration business. Concurrent to the exhibition, on all the 3 days, we will have a seminar which will have speakers of repute, both from India and abroad. We have also conducted a hackathon for startups and students along with the Anna University incubator. We had more than 120 teams participating, and 4 teams have been shortlisted to display their ideas at this exhibition. The RefCold Copeland Awards will also be distributed during RefCold, and if any of you who are participating today have any interesting products or projects in the refrigeration space, we would urge you to participate in the RefCold Awards. The time is still open. For visiting, we encourage everyone who is here to visit RefCold, and we assure you that it will be an educative and enthralling experience. To visit RefCold and to participate in the awards, please visit refcold.in and register either for visiting or for participating in the awards. Looking forward to seeing all of you at RefCold 2023. Praveen, can you please put on the RefCold video?
With the exponential growth in the Indian cold chain industry, it has been termed as a sunrise sector. Still, India faces an acute problem of appropriate refrigeration facilities, leading to 1.3 billion tons of food perishing in India. With a large spread of arable land, India is the world's largest producer of milk, fruits, vegetables, seafood and meat. Over 80% of the cold chain industry in India is unorganized and uses outdated and archaic technology, resulting in gross inefficiency and food loss. The cold chain industry is expected to grow at a CAGR of 14.3%. With the advent of food delivery, favorable government policies and innovative technology. With this market growth potential in perspective, we introduce South Asia's premier refrigeration and cold chain exhibition, RefCold India, which has a rich legacy of connecting experts and which enhances opportunities. After successful editions in Ahmedabad and Hyderabad, RefCold India is all set to catalyze the growth from the 12th to 14th of October 2023 at the Chennai Trade Center.
I welcome all of you to Chennai.
With a coastline of almost 1100 kilometers, Tamil Nadu has been identified as a champion sector for boosting exports and helping the state realize its goal of becoming a $1 trillion economy by 2030. RefCold India is a state-of-the-art exhibition positioned at the very horizon of innovation. Key progressive innovations of the industry will be on display, with insights by the decision makers. With over 200 exhibitors, the exhibition would feature an innovation zone and a B2B networking area. RefCold India caters to industries such as fisheries, agriculture, horticulture, pharma, dairy, poultry, food preservation and reefer logistics. The RefCold India Awards Night will highlight and honor those at the forefront of this burgeoning industry. The Indian Society of Heating, Refrigerating and Air Conditioning Engineers is an organization dedicated to the advancement of the arts and sciences of the HVAC-R industry. Informa Markets in India is known for its expertise across the B2B exhibition sector and its ability to create innovative business platforms. It has collaborated with the Indian Society of Heating, Refrigerating and Air Conditioning Engineers to present RefCold India 2023, South Asia's forefront exhibition for the refrigeration and cold chain industry. We invite you to join us in Chennai from the 12th to the 14th of October for RefCold India 2023, South Asia's premier refrigeration and cold chain exhibition.
Mano, can you please introduce Mr. Riaz?
Good evening, everyone. It gives me a great pleasure to introduce Mr. Riaz Khan for our webinar this evening. Mr. Riaz Khan is working as a senior manager, marketing cold chain for Copeland, India. Riaz has worked in various functions, including strategy and product planning, marketing, business development, and digital marketing and communication. He has an overall experience of over 15 years. Mr. Riaz Khan holds a bachelor degree in mechanical engineering from Aligarh Muslim University with post-graduation in business management from Indian Institute of Management, Indore. Copeland is a strong supporter of RefCold 2023, not only for this current edition, but also for our earlier editions as well. We are keen on listening to you, a presentation, Mr. Riaz Khan. Over to you now.
Okay, thanks to the RefCold team for giving us this opportunity to share our perspective on the refrigerant transition for India market. So I will just share the screen and take you through.
Once Mr. Riaz starts, I would request Praveen to put everybody else on mute.
So can you see my screen and presentation?
Yes, sir, we can.
Okay, thanks. So let's start the discussion. So, we will be using the terminologies like A2L, A1, A3. So for a common understanding of all the audience, even though all are more knowledgeable than me, I just recap of like how we basically, denote the refrigerants, what is the nomenclature. So if you see the right side of the presentation, so you have like A1, which is like non-flammable and non-toxic. Then we have B1, which is non-flammable but toxic. And once we go up, adding to the numbers like A2, A2L, A3, it means we are increasing the toxicity, but we are we are increasing the flammability, but we are keeping the minimum toxicity. But if you see the like B1, B2, B3, it means we are basically keeping the toxicity, then increasing it further up. So basically when we say like A1, it means clearly like it has very, very low toxicity and there is no flame propagation at all. So when we say A2L, basically we increase the flammability, but that is mild. So when we say A2L, it is like a class of refrigerants which have lower toxicity and lower flammability rating. Now, why we prefer these refrigerants? Because their GWP rating, this is global warming potential rating is below 300, normally below 300. And what is the composition of A2Ls? They are hydrofluoroolefins, pure HFOs, pure HFCs, blends of various components are there. So it can be anything among these four. They, like, what are the common HFOs which are being used currently in air conditioning application? We have 1234YF and 1234ZE. For refrigeration application, commonly used A2Ls, basically HFOs are R455A, 454C, 454A. And if we see what all are the currently used refrigerants, so we have HCFCs R22, which is going to be completely phased out in India very soon. Then HFCs, which are 134A32, then blends, and then hydrocarbon, which is R290. So this is just an overview of the nomenclature and how we denote the refrigerants. Coming to like what is driving this transition to A2L or CO2 or anything, because we are signatory to certain protocols in the global world. So now we have to reduce the global warming potential, and refrigeration is air conditioning and refrigeration primarily are one of the key contributors of global warming, basically gases. So if we see in refrigeration, because ref cold is primarily refrigeration, so we the most common refrigerant that we use in refrigeration is R404, which is having a GWP of around 4000, basically 3922. Now, as we have to reduce the GWP potential, so we have to go to the left side. And as we go towards the left side, you can see we have a intermittent transition of around 1270, basically R448A, 449A. And then if we want to reduce further, then we have to, go towards A2L. Now, what is happening is, like, if we go towards left side, either we are increasing the toxicity or we are increasing the flammability. So that's why you can see if we have ammonia, like toxic, but we have R290 also in this zone. I will just take a pointer, which is flammable. So A2Ls are mildly flammable, and their GWP, basically potential, is under 300, and that's why they become a choice of refrigerant for a transition from R404A towards the zero GWP, basically natural refrigerants. Now, one can argue that CO2 is also there, and definitely CO2 is there, but CO2 is a high pressure refrigerant, and because of the critical temperature of CO2 very low, around 31 degrees, CO2 poses a variety of challenges in design and the cost of the equipment also. India being a developing country, cost many a times is one of the key consideration when we try to go for a
Mr.
new
Riaz,
system.
I'm sorry to interrupt. I'm getting some messages in the chat box that you're not very audible. Can you?
Okay, so can you hear me, sir, clearly? Because I can hear you.
I am able to actually hear you clearly. Praveen, is it okay now?
Audio seems fine for me also, sir.
You're fine. Okay. Okay, fine. I think some people are not able to.
Yes, sir. It's absolutely fine with me too, sir.
Okay, then we go ahead, please.
Okay, thanks. So CO2 primarily, poses certain challenges on the design front because of the lower critical temperature of CO2. We can control that refrigeration cycle, that's not a problem. But then it also increases the cost of the equipment. So, and it's a high pressure refrigerant, and refrigeration has been traditionally medium pressure range, like 404A and 407AF. Now 448A, 449A also falls in the similar range, and A2Ls also fall in the similar range. So what we see is that, like India can have a, gradual transition from a higher GWP to a lower GWP refrigerant. And first it can be 448A, 449A, and then we pass through the A2L area, basically. So now A2Ls being mildly flammable, but when we choose a refrigerant, actually, we have to consider a lot of other things also, like, because we have compression devices, we have evaporator, we have condenser design. So when we change the refrigerant, we have to see, like, there is no other issue which is cropping up in other parts of the refrigeration cycle. So that we will tackle one by one. So if we see the commercial refrigeration landscape and plot different refrigerants on a scale, on the right side you can see capacity versus R404A, and on the left side we have capacities with versus R134A. So you can see, like if we see R448A, 449A, it is it is more than 100%. It means same compression device, similar system design will be delivering more capacity. Okay. And it will also have a GWP level which is closer to 1273, around 1300 basically. So we can achieve this. But if we see the A2Ls like 454A, 457B, we can achieve a higher capacity as compared to 134A because the density is higher. More mass flow rate definitely means more capacity. And and the capacities versus R404A are also comparable. Similarly, if you want to use 134 R1234ZE for refrigeration, you cannot use because it is a lighter refrigerant, low pressure refrigerant, and its capacity drops drastically even when we compare 134A and 404A. So we from this chart, what the basically the message we want to give is, like, we can use A2Ls when it is compared with the capacities of R134A and R404A. The capacities are comparable for certain A2L refrigerants, and their GWP level is well below 300. So it serves the purpose of lower GWP, and the capacity duration, basically deterioration, is not there. Now coming to the other parameters, when we compare A2L as a R404A alternative. So one is GWP, then flammability, compressor capacity, compressor efficiency, discharge temperature, glide, and basically the lowest temperature is subatmospheric temperature. So when we compare with R404A, taking R404A as a baseline, you can see that it is having higher GWP level, and these A2Ls which we have highlighted in a box are well below 300. Flammability, A1 basically non-flammable, but these three are flammable, mildly flammable. Compressor capacity, when we compare, same compressor is using R404A, and if the same compressor is using R455A, then there is a capacity improvement of 1%. But if we use R454C, the capacity decreases by 8%. So if our consideration is capacity, then definitely R454C is not the choice of refrigerant. Then compare R454A, the capacity improves by 9%. So it is showing an improvement in the capacity. But if we see R515B or 1234YF or 471A, the capacity decreases drastically. It means these refrigerants cannot be a replacement for R404A, because if the capacity decreases so much, it means we have to use a larger capacity compressor, which will increase the cost of the equipment so much, it will become basically unviable. So we keep our discussion basically to these three refrigerants, 455A, 454C, and 454A. Now coming to compressor efficiency, you can see, like, if the same compressor which is using R404A is using 455A, 454C, and 454A, all three show a positive improvement in efficiency. So it means they are using lesser power as compared to the when they are using R404A. So all three are good. Now coming to discharge temperature, a mild increase in discharge temperature, which is controllable as compared to R404A. Now coming to the evaporator glide. So what happens is that, like R455A and 454C, 454A, only 455A is showing a very high glide of 22 degree Fahrenheit. Now you all know glide basically is due to because it's a mixture, and all the components are not evaporating simultaneously. Just give me a sec, because I'm in a hotel, so it's somebody is alive. Just give me a sec. Okay, sorry for a little disruption. So it means when we take evaporator glide as one of the criteria of refrigerant selection, we can strike out 455A because it is showing a higher glide. Because if the glide is more, than evaporator design, condenser design, all have to be very, have to be changed. So, and coming to the lowest temperature which can be reached, so these are like in the range of like it is -50 for R404A, but still we can reach -44 when we choose R454A. So what we want to show here is that A2Ls, when we analyze them on a certain scale of GWP, flammability, compressor capacity, efficiency, discharge temperature, glide, and subatmospheric temperature, the lowest temperature basically, then 454C and 454A. These can be the two refrigerants which can replace R404A when we want to try A2Ls in our systems. So this is the refrigerant property based selection. Now, if we want to use basically flammable refrigerants, now we have to be very careful because any hazard situation actually is going to be detrimental not only for the material which is stored inside cold rooms and like if we use them in supermarkets, but it is very hazardous for the life of the people who are there. So as now A2Ls are being actually gaining prominence in US and elsewhere, so UL has worked for the product safety standard. So UL 60335-2-89 is the product safety standard, which was published in October 2021. It talks about mechanical, electrical, refrigerant safety. It also defines the charge limits and leak mitigation requirements. So based on our system design, basically it has defined the charge limits. And if the charge quantity goes up, what should be the leak mitigation requirement in case any leak happens? So that is outlined there. And then it also, it gives the product testing requirement in an annexure called annexure CC, in which if some company wants to launch any equipment which is built for A2L refrigerants, then what should be the testing requirement? So this is the product safety standard which is used in product design. Now coming to the installation, so ASHRAE also has taken the notice of this development of A2L refrigerants, which is coming up very fast, and they have also harmonized ASHRAE 15 standard with UL 60335-2-89. It is a standard based on occupancy type, like it is storage or it's for for a building, and then it also includes mechanical, electrical, refrigerant safety. So these two standards actually are to be used when we are actually designing the equipment and also when we are commissioning the equipment. So these two standards are there. Now coming to key considerations for A2L system design and application. So when we compare A2L, we always will be comparing with the flammable refrigerants, like what is the condition with flammable refrigerant and how A2Ls basically can be used in place of flammable refrigerants, and what will be the mitigation requirement. So there is something called lower flammability limit, which we will be using multiple times in the calculation of like what should be the charge quantity. So a flammable event can potentially occur when concentration of leaked refrigerant exceeds its lower flammability threshold and is exposed to a source of ignition. So for any basically ignition to happen, the concentration of the refrigerant should be more than lower flammability limit, and it should be exposed to a source of ignition like a charge or a static charge or a fire, and so then only something can ignite. So A2L's lower flammability limit is 8 to 10 times of R290. So R290 is highly flammable, but A2L's LFL is 8 to 10 times. Other technical term is minimum ignition energy, MIE. So what should be the minimum ignition energy to ignite basically flammable mixture? So R290 can be ignited by static electrical discharge. That's why highly flammable refrigerants actually and environments require ATX, ATEX basically certification. But A2Ls, when they are actually, if some leakage happens, then they should be exposed to an open flame or a strong electrical source energy. Then only they can ignite. They cannot be ignited just like R290. And the burning velocity SU. So when we ignite any highly flammable refrigerant like 290, it's an explosive effect, and the velocity of flame propagation is 46 centimeter per second, whereas A2Ls have a burning velocity of less than 5 centimeters per second. So it is not having a explosive effect as compared to a 290, which is having an explosive effect. So we will be using these three terms repeatedly. That's why I explained them. So if we have a self-contained system is defined as like equipment consisting of a completely factory assembled, factory charged, and factory tested system in which all the refrigerant containing parts are permanently connected at the factory in the controlled atmosphere basically. Thus evaporator, condenser, compressor are part of a package unit. So this is basically a self-contained system. So if a self-contained system is designed using for A2L refrigerant, then what is the equipment charge limit is 8 meter cube into lower flammability limit for a closed door design, and 13 meter cube into lower flammability limit for an open door design. For example, R454C with lower flammability limit of 0.291 kg per meter cube. So it is like 1 pound in closed case and 3 pounds in open door case. Basically, the design is there. For flammable refrigerants which charge, if the charge quantity is greater than 150 grams, it must pass annexure CC that we discussed earlier with the risk mitigation and the leak detection equipment. So, but if we are using A2L and if M1, the equipment charge limit is less than M1, then there is no additional risk mitigation requirement, and leak detection measures are not required. Only passing the annexure will be okay. Because additional risk mitigation and leak detection all involves adding more and more hardware and sensors. So if we add more and more hardware and sensors, it is going to increase the cost of the equipment. That is why then whole thing will be economically unviable. So if we use A2L and if we keep our equipment charge limit less than M1, then definitely there are no additional risk mitigation requirement, and leak detection measures are not that much required. Only passing an actual CC will be done. So this is for a self-contained system. When we compare a remote system that we see mostly in our cold rooms, in which the condensing unit is basically placed outside the building and inside we have indoor unit like evaporator. So mostly this is the design configuration in cold rooms that we all see. So again, the product safety standard remains same 60335-2-89, but you can see the change in the charge limits M2. We can say M2. So it is 260 meter cube into LFL. So what difference it creates is the maximum allowable charge size would be close to 75 grams, and it can deliver up to 60 HP of cooling capacity. So you can see like when we change the design configuration from a self-contained system to remote system, then our permission basically to achieve to increase the charge goes up very high, and then the limits are higher, then basically we can deliver higher cooling capacity. But as the quantity of charge is higher, may require additional safety mitigation measures, which will be as per the standard. But still it is what we want to show here is that because of the large charge quantities, because if we use our 290, the quantities are going to be very less, which are not enough for a bigger cold room. But here you can use A2L refrigerant for a bigger cold room also. Now coming to the guidance. So following the, there is an annexure 101.dvu and annexure 101.dvg. So in the UL standard, so systems should be designed to detect, isolate, and disperse A2L refrigerant leaks via combination of controls and tools. So there is a annexure in which it is advised like how systems should be, like designed to detect and isolate refrigerants. So we have to use a combination of leak detection sensors, isolation valves to limit charge release if at all any leak happens, and electronic controls to shut off compressors in case of any leak that is happening. So now we can see, like, if we change the design, then our charge quantities can go up, and we can use A2Ls for a larger cold room application. Now coming to the like electronic component considerations. So working with the flammable refrigerants in a commercial refrigeration system requires a special attention to the electrical componentry, because there can be spark, there can be static charge also. So that's why we have to be very careful because the refrigerant may come in contact with these components. So then all these relay contactors, devices used for switching electrical currents on and off, controllers, variable frequency drives, electrical enclosures box, which are in which a full system must be contained. So all these things have to be used, which are certified for to be used with flammable refrigerants. And as per the standard, these common components must be individually certified as per annexure 101.dvl, or within an enclosure as per annexure 101.dvm. So as per the standard, we have to see uh, individually, and then within enclosure it has to certify the requirement as per the standard. So A2L application, what we are seeing mostly in US, because in Europe their agenda is to reduce the GWP level below 150 now. So they want to go towards primarily with CO2, and being a low ambient continent basically. So quite possible for them to control the CO2 refrigerant easily, as compared to a country like India, which is the ambient is quite high. So we have seen in US like Indore units like display cases up to 6 HP. For retail outlets, small convenience stores are being designed and used with A2L refrigerants. Outdoor units up to 10 HP, like convenience stores and modular cold rooms, and even for the larger cold room also, because there the height restriction is not there, and larger rooms can be there. So they are also for a distributed and centralized systems, people are using A2L refrigerants. So if we see the controls for A2L systems, you can see, like, in a A2L system, we have to use electronic control valves, sensors, expansion valves, solenoid valves, oil management system. These are all our basic components which are used in a refrigeration system. So we have to make sure before using A2L refrigerant that all these components can be used with a flammable refrigerant, and they are certified individually for them, and pass that annexure that is outlined there. So basically what we are trying to do is we want to make the environment more and more sustainable by reducing the carbon emissions. So now we are signatory to the protocol, so we have to move towards lower GWP refrigerants, because then only we can be like compliant to those regulations. So this is all from my side. If someone has questions, maybe we can take it up.
Can we request all of you to post queries on the chat box, please? Okay, I'll start with the first question, Mr. Riaz. You
Yes,
are
sir.
talking about synthetic refrigerants. What about the natural refrigerants which have been looked at as alternatives. Where do they stand in the whole gamut of things?
Natural refrigerants, if you see in this chart, actually, if we see natural refrigerants, then we have hydrocarbons, which are highly flammable, and then we have CO2. So CO2 is one of the choice of refrigerants, which we call as a future-proof refrigerant because its DWP level is close to zero. So that is one of the solution for refrigeration application. But as I shared earlier, that CO2's critical point is hardly 31 degrees. And India ambient conditions are quite high. In order to use CO2 as a refrigerant, we have to use gas coolers and we have to make the cascade design for getting a better efficiency. So that's why using CO2 in a high ambient country currently directly from 404 to this high pressure refrigerant may not work actually. People are people can be taught gradually to use the higher pressure refrigerants, and the cost of equipment will also not go that much high when the gradual adoption takes place. Then coming to R290, which is hydrocarbon, but it is flammable. So the quantity of charge quantity in case of flammable refrigerant is very, very limited because these are very highly flammable refrigerants. So that's why we can go towards natural refrigerants like 290 and CO2, but 290 cannot be used in larger quantities, and CO2 can be used, but again the system design and the cost of equipment will be high. That is why we are advising people to go gradually from the 2000 level of GWP to come to 1300 with 448A, 449A, and then drop to 300 level and gradually start using, mildly flammable refrigerants. Quite possible after 2-3 years, because people are research is always going on, we may get some more advancements and we may be able to use flammable refrigerants like 290 also in larger quantities. But currently their charge quantity in equipment is limited. That's why we cannot use.
Thank you.
Sir, this is Krishnamurthy. I am handling the question answer session now. Mr. Dinesh Sharma wants to know what are the main sustainable materials for refrigerant?
Main sustainable materials for refrigerants. You are asking about refrigerant composition? Actually,
Dinesh
Yes,
Sharma,
sir.
can
Yes,
you?
sir. I was asking for the refrigerant composition means just in the last question you have talked about the CO2 and 290.
Mhm.
So I was talking about towards nature inspired something we can do like uh, what we can do. Suppose inspired from nature because we have done many things from nature. So can we have some idea about in that direction, sir?
Actually, people want to use natural refrigerants like CO2 and R290 as I shared, but refrigerant has to have certain properties for a closed loop system, because if you recall, refrigeration systems earlier using steam and everything, were open loop systems in which we used to use a large quantity of water and use evaporative coolers for cooling. But as we want our systems to be more and more compact and work in a closed loop cycle, currently what we see is a natural refrigerant is one of the solution is CO2 and 290, but they both have certain merits and demerits. So as per my understanding, these two are the solutions as per the natural refrigerants. Others are mostly synthetic.
So can you again highlight about the CO2 refrigerant, why it is not commercially viable now as of
Actually,
now?
when you are using a condenser, then heat has to be rejected from a higher temperature to a lower temperature source, right? To a lower temperature body. So if our say ambient temperature is say 45 degrees, then condensing temperature should be higher than 45 degrees, so that we are able to transfer the heat from our system to the environment.
Yes,
But
sir.
in case of CO2, the critical temperature is hardly 31 degrees.
Okay.
By after 31 degrees, there is no temperature and pressure relationship for CO2. It is in a supercritical zone. When we don't have that relationship, then designing a condenser is not possible. Then we have to use a gas cooler to cool down the, you know, CO2 from a supercritical zone to a subcritical zone, and then use
Cost,
many
I think it,
components in.
yes, yes, yes. It will
Yeah,
increase the
it
cost
will
also.
add cost. It will be adding complexity to the system.
See,
That is
we
the
could not,
issue.
we could not find the characteristic like CO2 for the refrigerant purpose so far, I think.
Actually, CO2 was used in early 1900s also. I think CO2 started with in year 1890 or year 97 somewhere. So people started CO2 long back. People know CO2 as a refrigerant, but these these issues actually prohibited use of CO2 as a major refrigerant for refrigeration purpose.
Okay. So what other, CO2 is a gas because we are talking about the CO2 emissions and everything everywhere. So it is surprising that we can use, or it is possible sometime later that we can use it as a refrigerant. And again,
We
the
are using, so let me correct myself, we are using CO2 as a refrigerant. It is possible. It is being used in Europe on a larger scale. But I am saying that for India market and India ambient conditions, because many a times the cost of the equipment takes a very, very high precedence when we select the equipment. And, so that's why I'm saying that for India market, using a refrigerant like CO2 may not work in the current scenario. It may work after some time when people are used to using high pressure refrigerants and the cost of the equipment is also coming down. In Europe, many countries are doing, the governments are subsidizing in some way, then only people are able to adopt the CO2 as a refrigerant. So that thing has to come to India, then we may be able to use it. But India being a higher ambient country, so there will be more and more the requirement of gas coolers and everything. So that will be there.
no other gas is found like CO2 properties. Is it so? Sir?
Yeah, can we move on, Madhu?
Okay. Yeah, Mr. Lakshmanan has the 400.
Sir, before that, you have a question from Mr. Narayan Menon, sir.
Yeah,
He is asking, can you please re-explain equipment charge limit M1 and M2, the calculation methodology?
Just a doubt there, Narayan here. Thank you, Riaz, for the presentation.
Yeah.
To counter Riaz Khan on the CO2 part.
Sorry? Yeah, Riaz, I just wanted to know one thing is what is closed door design and open door design? And the value, it keeps varying, right? If I'm not wrong.
Yes. See, when we are saying as a closed door and open door design, I will just take it.
Yeah.
One is that if we see a refrigeration system like a refrigerator which we use in our homes, it is a closed door design.
Okay.
And when we go to a supermarket and we see an open deck chiller in which bottles are kept and we can, pick it up without opening the door, it is an open door design. Something like that.
Okay. That is one thing. And one more thing, Riaz, what I wanted to know, when it comes to comfort applications, okay, typically we don't have a refrigerant which has a very good GWP. We still use 407C, 134A. So are you telling that most probably CO2 is the refrigerant which could most probably come into the comfort world also, rather than the industrial side?
Comfort application you can see here, like 1234 YF is used. And its capacity is close to R134A, and it is being used in Europe also. So this is one of the refrigerant. And then you have 454C, 454A, which can be used in comfort application. That is not a problem. People are using, actually Carrier is having a system which is for comfort application and using A2L. But again, when they are designing a system, then as it is a mildly flammable refrigerant, they have to make sure about, like the technicians who are installing the air conditioning, air conditioners in the field have to be trained for using, flammable refrigerants. So once the demand for flammable refrigerants, or the government puts a condition on the GWP levels, and then people are forced to use A2L, then they have to invest a lot of time on the training of personnel also, because currently our technical team, you can see they are more of a, the guys who have learned in the field. They are not so educated,
Not major
specifically in
problems.
that's why.
Okay, thank you so much, Riaz.
Okay, then we have
Mr. Lakshman Subramaniam wants to know the 400 series
yes,
refrigerants are a mixture of different refrigerants. In case of
yes.
leaks, the entire charge of the system will have to be evacuated and fully charged again with a new refrigerant.
Actually, if, uh, so it's definitely in case of a leak, then first of all, there has the if the leak has happened, then it is always advisable that we do the vacuuming and then charge again and check whether from where the leak has happened and close that leak first. So that is you are right, that is one of the standard practices that we advise to be used in the field. Because if there is a leak, then there is a quite possibility of moisture going into the system, and if the moisture goes into the system, then it breaks up the oil which is in the compressor into acid, and if there is too much acid, it is going to corrode the internal parts and sometimes the brazing also to some extent, and it will create further leaks. So that's why it is a good practice to evacuate, charge again, and close the leak completely, and uh, follow this practice.
Oh,
And
Riaz, here, and,
yes, sir.
your point is okay, but then since it's mixture, you don't know which gas has leaked, which component of refrigerant has leaked. So if you top up, then there's a major problem. The gas behave in a totally different way than what it is supposed to do originally.
Yeah, you are right. If because yes, you are right. Because let me explain what I understand from the systems perspective. What I know may be limited, but whatever I understand is, like, if the leak has happened in the liquid lines, okay, then there is quite possibility, like, because the refrigerant portion which is going to like vaporize in the later, like later actually will be uh, uh, is not going to be an issue. But if the leak has happened in the suction line, if everything is vapor, then the components will be different. So you are completely right in saying that if we are using a refrigerant which is a multi-component refrigerant, then it's always better to vacuum it completely and then charge the refrigerant. You are completely right in saying that.
Yeah. Then on the CO2 front, so it made a point that it is not popular. It is gaining popularity in India, and I am personally involved in one of the projects where we are installing a CO2 refrigeration system, both heating and cooling together. The main advantage of CO2 is we can get very high temperatures on condensing on the higher side, and also correspondingly you can get lower temperatures. So it is not necessary that you have to necessarily condense the gas. It can work in subcritical or even transcritical system without any problem. It will be a
Yes,
mixture
sir.
of
Yes, sir. Actually, for that, what we do, we know that actually we use a cascade system in which one system can give a low temperature and medium temperature refrigerant. But again,
slightly
yeah,
different system. I'm talking about a transcritical system entirely
mhm.
operating not in two stages, not in cascade, not in two stages. It is
That
gaining
is possible.
popularity, and
That is, but
is being Professor
that is
Maya.
that is that is definitely, sir. It is gaining popularity. It is there, and we also have even scrolls which can use CO2 refrigerants for both subcritical and transcritical application. Whatever I was saying was from the perspective of a large scale adoption, because in India, is still people are not used to using high pressure refrigerants, and system cost also goes up. So you are completely right in saying that people are making ammonia CO2 cascade also, because ammonia can work on the outside and CO2 can work on the inside side when we are making systems for the food processing application. So in India also people are using CO2, but if we see market as a whole, we see that A2Ls having a better chance because of the like the refrigerant properties versus CO2, and their close proximity to R404 when it comes to the different refrigerant properties that I shared. But you are completely correct in saying that people are using in India.
Okay, thank you, Riaz.
Sir, Mr. Dinesh Sharma wants to have further details on the topic which you spoke about. Can I share your email ID with him, sir?
Yeah, please, you can share with anyone you want, and
I'll
they
do
can
that,
mail
sir.
me, and if required,
Okay.
they can mail me, and we can even have a session which is dedicated for some people. That's not a problem.
Fine, sir. We have the recording of the entire webinar. Mr. Umesh Shakla wanted to have the recording. We will share it with him separately, sir.
No problem, sir. It's okay.
Okay. Mr. Rohit Sutar. Oh, President pressure same as R404A.
Rohit Sutar, 400 group refrigerant pressure. I am saying it will be in a similar range actually. Similar range, because if you recall this chart which I had showed, so then you can see like I have not shown pressure here, but it will be in a similar range. You can probably we can refer to this chart actually, this one. So it is basically discharge pressure, but the range will be similar. It won't be too high.
Okay. Fine. Any more questions from the forum, from the participants? Okay. Yeah, we will share it with you, Mr. Umesh. If no more questions, shall we move on to the vote of thanks by Gokul?
Yes, please.
Gokul? Gokulnath?
Yes, sir. Can you hear me, sir?
Yeah, feeble.
Sir, hello?
Yeah, you're audible, Gokul.
Okay, sir. Okay, sir. Hi, very good evening to all of you. With this, we come to the end of the program. On behalf of ISHRE Chennai chapter and RefCol 2023 organizing committee, we thank Mr. Riaz Khan for sharing us so much knowledge within a short period of time. We thank Copeland once again for being one of the major sponsors for the RefCol 2023. Once again, I welcome all the participants of this seminar to the RefCol 2023, which is happening on 12 to 14 October at Chennai Trade Center. I think we will be able to see live Copeland stall over there. Thank you all. With this, we'll end the program.
Yeah, my only request is, Riaz, can you just show your face for 2 minutes? I understand you're in a hotel room because you've been there for all the people who have listened to you. Just for 2 seconds, you can show them your face. Thank you so much. Thank you.
Am I
you so
visible
much.
now?
Yeah, you
okay.
are.
Thanks.
Thank you so much for agreeing to be.
Thank you, sir.
Okay, thank you, sir.
Thank you so much.
Thank you, sir. Yeah, it's clear now.
Yeah, absolutely. Thank you so much.
Thank you.
Thank you so much.
Bye.